All right, so we're going to start learning about this G&M code. And G&M code is the way that we communicate with machines. All right, it's the way that we talk to computer numeric control pieces of equipment. So G&M code is pretty straightforward. Once you kind of get the hang of it, you're going to be doing pretty well with it. It's, in a sense, it's a little bit of a language thing. Like it's not as in depth as like Spanish or French or whatever, but it's still a language thing. So today it says we're going to start a new unit about G&M code, and it's how we communicate with CNC machines. At the start, we're going to learn how to write code by looking at the files that are attached to this post. So let's see here, Alt-Tab. So I'd like to say I'm sorry, but I'm probably not really, because we're going to take a look at this PowerPoint here. And I'm going to ask you some questions about it that you're going to refer back to that G&M code reference sheet. So keep track of that reference sheet because you're going to need it in the next few days, weeks, months, whatever. You should have all your mass property stuff done. The model should be made, the math should be done and turned in. So if it's not, you need to finish it, and you're going to have to do that asynchronously or see me. I sat with Ethan the other day and we worked through 3 of the 4 problems. I'm happy to do that with anybody who needs that help. I'll work through the problems with you. And I think Ethan was pretty successful in it anyways. So G&M code. So we're going to reference that sheet that you got in front of you. And the very first CNC machine I ever saw was at a school called Batavia High School. My dad was an industrial arts teacher there. Industrial arts is what they called technology before we called it technology. They just called it industrial arts. And this is how they used to program CNC machines in the late 60s, early 70s, before the onset of computers like we have today in front of us. So this is a punch tape, they call it. As a matter of fact, well, it's not so much funny, but the story is that when I came to work here, I was sitting in the interview process and they said to me, hey, we've got a CNC machine that we're going to put in the shop over here next door. And I said, oh, really? And they said, yeah, here, we'll go down and see it. So they took me down to the storeroom down the hallway from here, and I walked in and I looked at it, and it was a big machine. It was easily 3 times the size of that red toolbox there. And I looked at it and I saw on the end of it something that I hadn't seen since like 1975. It was a punch tape reader and also a generator for the punch tapes. And they said to me, so where do you want us to put it in your room? And I said, no, thank you. Well, why? It was probably a fine piece of equipment, but it was an antiquated system to input the information into it. Punch tapes were a problem because these tapes had to stay pristine. They couldn't get folded, they couldn't get twisted, they couldn't get anything, or they would not work. So I was not, I was like, okay, I don't want it. So they did sell it to somebody. I don't know who or how they got rid of it. But anyways, punch tapes got replaced by computer chips, basically. So I don't know if there's any punch tape machines still out there, but there were anyways. So my dad's shop, the school that he taught at, they had one of these machines with a punch tape on it. Now, here is a CNC. This is a pretty big machine. If you take a look in the picture up here, what they're doing is they're machining an engine block, okay? And what G&M code does, as I've kind of alluded to already, is it translates human language into a machine language. And you type it into a computer, or it gets generated by a program. A little later on, we're going to learn how to do what's called CAM, computer assisted machining. And in CAM, you are going to use the computer to generate the G&M code that right now we're going to learn how to write by hand over the next couple of days. Anyways, so this is what's called a sample program block right here. It's N1, then space M06. Now, on your reference sheet, you're going to find M06. So, Jordan, can you tell me from your reference sheet, what does the M06 mean? That's correct. M06 is a tool change. It's in the column on the right-hand side. M spells or stands for miscellaneous, okay? T1. Anybody want to take a guess? Well, no, I'll tell you what. Travis, what does the T stand for in T1? That's correct. It's tool number. So it's saying, N, by the way, what's N? N is the block/line number. So N1 is the first command in a series of program blocks that will differ from this one, but you build on it. So that's the first thing. And it says M06, which is a tool change. That means put a particular tool in, and that T1 is the tool number. So the block sequence number, take the mask off right now. The block sequence number is that N1. M06 is the miscellaneous code for a tool change. And then T1 is the tool number, like I've just discussed with you. After you do the code, what you do is you put in a semicolon. And a semicolon tells the computer that you are going to now add a comment. That's what this says. It says change to tool number 1. So the computer doesn't understand that comment, but we as humans know what it means, all right? So if Travis writes code and he puts a comment on it, I can easily identify what he's trying to do with the command because it says change to tool number 1. So then I can take a look back at it and go, oh, M06, that's our tool change, and T1 is the tool that we want to put in there. So the comments are very important for our programming. So you'll do this kind of stuff, and you'll also add comments. All right, N02. So we had N01, now we have N02. So this is the next thing in our list of commands. What does M03 mean, Nick? Yep, the spindle motor is the part that makes the tool rotate, okay? That's the spindle motor. So that turns on the spindle motor. So Alex, then it says S1500. What does S stand for? Pardon me? Spin. Did you look at the reference sheet? What's the letter S stand for? It's under frequently used characters. Spindle speed. So it's how fast that thing is turning. In this case, the speed is 1500. Now notice, between these letters, the letters and the numbers, there's no space. Okay, one of the mistakes that I see students make quite a lot when we're programming by hand is they put a space between the N and 0, or through the M and 0, or through the S and the 1. You don't put a space between those things. All right, so it's the letter, then whatever the command is after that. All right. So here is our miscellaneous code. Turn the spindle on. Here's our spindle speed. Now, here we go. All right. DJ, what is the N03? What does that mean? What did N stand for in the first two examples? It's the line number, okay? So this is the third sample program block. All right, so we'll come back. Nick, G90. What's a G90? Yes, absolute coordinates means we're going to find a point and we're going to call it 0, 0. So if I want my machine to move, if this is my table right here, if I want the machine, the tool is spinning right here, and this is 0, 0, and I want it to go to 1, 1, which is 1 on the X and 1 on the Y. It moves over 1 unit and then up 1 unit. So it's working from this point. Now, if I want it to go to 2, 2, and this is all that geometry stuff that you've learned in school, practically applied. So if I want it to go from 2, 2, it's going to go back. It's going to think to itself, okay, 0, 0 is over here. 2, 2 is over 2 and up 2. So it's in absolute. It's not moving from the 1, 1. It's moving from the 0, 0. So it's counting from the absolute coordinate of this thing. Travis, G01. That's right. Interpolation is how that's pronounced, but you were close. All right. So linear interpolation means it's going to move in a straight line. It's linear. That's what the word linear means. It means straight line. So it's going to go in a straight line. We'll change that eventually. Jordan, what do you think that X 0.5, Y 0.5, well, let's give you all four of them, Z0 and means? What is that telling the machine to do? Well, I guess I could see how you might think that. Take a look under frequently used characters, Jordan. You'll see X, Y, and Z there. All right. So those are the coordinates from 0, 0 that we want the machine to go to. So what we've just told it is that with the G90, that we are going to use absolute coordinates. And I'll tell you this right now, all of our programs are going to be written with absolute coordinates, okay? Everything we do is going to be. You can write them with what's called incremental, but we're not going to mess with that at all. So we're just going to use G90 all the time. Then G01, it's going to go in a straight line to the X value of 0.5, the Y value of 0.5, and then the Z axis, okay? The Z axis, if my finger is the tool spinning up here, that means that it's going to go from 0, 0, 0 over here spinning. It's going to zip over to 0.5x, 0.5y, and then it's going to come down and right down to the surface of our part, which is 0. Okay. F1. So, Travis, what does the letter F stand for on our sheet of fun here? Pardon me? That's correct. It's feed rate. It's how fast it's going to do this. So it's telling it right now that we're going to go XY 0.5, Z0, and we're going to do that at a speed of 1. Okay, so it's going to start over here. It's going to move over here and come down to 0. Okay, at a speed of 1. You can change that feed rate. and we're going to have different feed rates in here. So here we go, line number. That's our prep code, preparing code of absolute. It's our prep code for straight line interpolation. Oh, I should go back, whoops, here and say something. When you give the program commands, gosh, what's the word for it? I just had it a second ago. What it does is it remembers the command, all right? So a G90 is maintained by the program. You don't have to, on every line of code, type in G90 space G01 unless you're not doing a straight line, okay? So once you do the G90 one time at the beginning of the program, you don't have to repeat that ever, okay? The other code, G01, you might have to, if you change to like doing an arc, which we'll look at in this PowerPoint, you'll see that done. So then you might have to come back with a G1. But anyways, all right, so here's our X coordinate, here's our Y coordinate, there's our Z, and there is our feed rate. So these things, the N's, the G's, and the F's, those are called the character addresses or address characters. And they're a letter that gets used in G&M code programming to designate a class of functions. So the way that we want the machine to operate, okay? The numbers are what they call parameters. They're the attributes of a feature such as dimensions, and they can be modified. We can't modify the N's and the G's and the F's, but we can modify the things that follow them to suit our needs. One of these pieces, so like the G90 is referred to as a word, and the programming expression is formed when a letter is combined with a number. So letter and number together is a word. So it's like hola is in Spanish, okay? It's a word. A block is this whole combination of these words, okay? A block is a single line of code in a NC program, numeric control program. So here are some of the coordinates that we were just talking about, right? Here's G90, there's G00, and G00 is what's called a rapid traverse. The machine has, you can set a feed rate for things, but it also has a programmed in feed rate of that you activate with G00, where it goes real fast across the table and stops at whatever the coordinate is, all right, that you put in. That is a non-cutting move. You never use G00 when you're cutting into something. And the reason for that is what will happen is it will snap a tool bit or something else unfortunate. G01 we already talked about, which is straight line interpolation. And this is a cutting movement. You use G01 when you are have the tool inside of a part and you're cutting something. Now this is the next one is G02. That's circular interpolation. That is something that would replace the G01. So in circular interpolation, G02 means that you're going to want the machine to move in a clockwise direction. So it turns like you were going from 12 to 1 to 2 to 3 to 4, that's clockwise. Then we have G03, which is circular interpolation counterclockwise, going from 6 to 5 to 4 to 3, back that other direction. G04 we're never going to use, which is a dwell. G05 we're never going to use that one either. That's a pause. And then we are going to, I'm going to skip this and we're going to stop right here. skipping anyways. All right. So when we program arcs, all right, that's what the G02 and G03 do. They allow us to program an arc. There's two different methods to use for programming arcs. The first one is the one I just skipped through. It's called I and J. As a matter of fact, on a handout that you're going to be getting in the next class, you're going to see the I and J crossed out, basically, because we don't use it. It won't work with our CNCs. There are some commands that work with CNCs, and then there are some commands that don't work with CNCs. So the I and J doesn't work. So when we have to do an arc, and we will be doing arcs, it's a requirement of one of our projects here, this first project actually, you're going to use the arc technique, all right? So that's what's called method 2. It's an arc with a radius. So how that works is you use the absolute coordinates. So here's an example, N0, which is our first line of code, then G90, right? Ethan, what was the G90 again? Yep, absolute coordinates. And then we have N05, N5, and G01, X1, Y2. So, DJ, what is that line going to tell the computer? What is G01? Yep, it's linear interpolation. And what's the X and the Y mean? X1, Y2 mean? It's the location for the tool to start at. Okay, so you'll notice something here. Their numbers, they skipped from N0 to N5. And when you're writing your code, you might want to skip at least 2 numbers in between things. So the reason they do that is because if you have an error in your programming and need to add a line, your numerics stay in order. You don't have a problem with them. If you put in, if you have to insert a line here and it's N1, it won't mess up the rest of the code that you have written. Okay, so N05, G01 is linear interpolation, and you want the computer to move to the point X1, so it's over 1, and then you want it to go up 1, 2. So it's at this green dot right here on the screen up front right now. Now, it says N10, G02, X2, Y1. Alex, what would that command be doing? N10 is the number, right? What's G02? That's correct. So we're going from the green dot here to the blue. So it's going down this way. Alex, what is the X2, Y1? What does that mean? It's the next point. So we've told the machine to go to X1, Y2. We've told it to go clockwise, excuse me. And the point that it's going to go to is X2, Y1, and it's going to have this value right here on this one of R1. That's the radius, because the distance from here to here is 1. Distance from the center here to here is 1. So that's the radius. Okay, so those are absolute. This stuff down here is relative, but we're not worrying about relative. We're only worried about absolute. So this technique right here for doing arcs is something that you're going to need to know and be able to understand, all right? Other common G codes, G20, that means we're working in inches, because these machines will work in any units that you want. If you want to work in metric units, you can tell it metric units, which is G21. But we're always going to work in inches. G80, now that's a canned cycle and that's the cancellation of it. Can cycles are things like, they call them bolt hole patterns. You have a circle and has holes on a particular diameter or radius around. That's a can cycle. G81 is a drilling cycle with dwell. M00 is pause. We may use a pause someplace, but not frequently. M01, optional stop. And M02, we will use. That is the last command on any program that you write, is going to be M02, because it ends the program and it stops the program from running. M03 is turns on our spindle, so it makes the thing spin. So that gets used at the beginning of our program. And M05 goes at the end of our program before the M02. So it's M05, then M02. This order is flipped, but that's the way that you use those two. You turn the spindle off and then you end the program. M06 is a tool change. We will have to change tools. These tools come in all kinds of different sizes. The first tool that we're going to be using is an 1/8 inch end mill. An 1/8 inch end mill, what that does is that will cut a path that is 1/8 of an inch wide. So it's a pretty tiny end mill. I usually would, if I had thought of it, I should have gone and gotten some of the mills and stuff like that out of the shop. But anyways, so sometimes we're going to be using that 1/8 inch end mill, and then we're going to need to change to a bigger end mill, like a 1/2 inch. So when you do that, you issue an M06, which is a tool change. M08 and M09, we don't use those because we don't have any accessories. M10 and 11 also. M30 we don't use because it basically does that all on its own anyways. M47 is rewind. We're not doing a rewind of any kind. So some code, and this is what I was just mentioning a few minutes ago, is not required to be repeated every block, because the machine will use that code until you change it with another command. They call that, that's the word I was looking for, modal. All right, they call that being modal. You want to tab your marks away from the code to facilitate troubleshooting programs. You have to remark every line of code, because it makes it so much easier when you call me over and say, hey, Mr. Seward, my whatever isn't working. It makes it easier for us to kind of figure out what the problem is. So that is a requirement, that you're going to remark everything. You will specify absolute coordinates and inch coordinates at the beginning of your programs. We're not using relative, and we probably won't get into using metric, all right? We're going to use the tool change command to move the tool to a safe position away from your material and change the tool if it's necessary. Whenever we've got a tool at one location and we want to change from that 1/8 inch tool to a 1/2 inch tool, you make a Z move up, and then you're going to make a X or a Y move. It's probably a Y move backwards, so that you can get the tool away from the part, and then you'll be able to change it, or you bring it forwards. So we'll get to that. And you need to indicate spindle speed every time you turn on the spindle. Some more suggestions: move your tool to start position in 2 lines. First moves in X and Y. So I have my tool up here 2 inches above my work surface. Travis, you have your tool up here 2 inches above your work surface, and what you do is you tell it you want it to go to 1 or to X1, Y1. So it's going to move on a diagonal. It's not going to go over and then up. It's going to move from 0, 0 on a diagonal right to 1, 1. Then the second move is Z down, and you're going to go, this, by the way, the code to go from 0, 0 here to over here is going to be G01, which means interpolation, right? Straight line interpolation. X1, or yeah, no, it's going to be G00, excuse me, because that's a rapid. So you're going to go whoop, real fast. So it's going to be G00, X1, Y1 to go to this point. And then it's going to be G00, but you don't have to put the G00 in because you've already got it in the line before. You're going to say Z.1. So you bring your tool down to just above the surface of your material, okay, 0.1 inches, and then you tell it G01, which is straight line interpolation, Z minus 0.0625, which means it goes into the material and is actually cutting. And you'll have turned on your spindle and stuff like that. We've got a template that helps you to go through this process as we go through things. When you are done, you raise the tool out of the stock at the end of the program, and then you move the table to a safe position so that you can unload the part out of the machine and turn your spindle off at the end of the program. And then you use the very last thing is M02 to end your program. So here is this sample part, and this is something you might be actually doing. Well, you will be doing. You'll be writing code to make a letter block. All right, you may have seen those kicking around. I don't think I have one in here, but anyways, you're going to put your initials into a block, and you're going to use your full three first, middle, and last name to do this. So here's what they do. Here's what you do. First of all, you write your initial out on a grid, okay? We have a 0 point over here on the lower left-hand corner of this block, and then they have lettered each one of these points. So you'll see that the start of the letter M is an A, and then you'll notice that the next line up is a letter B, C, D, E. The machine is going to trace exactly from point A, which is at 0.5 comma 0.5. So it's over a half an inch and up a half an inch. Each one of these grids is 1/4 of an inch. So it's over a half and up a half. And then it says letter B, 0.5. So that means that's the X value. The first number is always the X value. So we're going to stay right on this line right here. And it says go to 1.5. So this point is going to go from 0.5 to 0.5. Come on, where's the cursor? There he is. Up to 0.5 comma 1.5. So that is the location. We're over half an inch and we're up 1.5 from the 0. Then it says move to this location, which is 0.875 comma 1. So on the Y value, we are 4 blocks up, 1, 2, 3, 4. And then on the X value, on the X value, on your X value, we're over 0.875. And then on our Y value, we're up 1. And then you go to D and to E. And then when you're here, you pick the tool up out of the material and you go to your next set of points. And here we go. They're going to write the program. So here's what I'm going to do. Since we got like 5 minutes left, I want to actually do this on Thursday with you. So we'll go through and talk about how that thing is programmed on Thursday and a little bit more in depth on this. Okay. So there we go.